Hello and welcome back to the lab. Today on the bench is not a restoration, more of an introduction. But before we get into that, thank you for everyone who continues to tune into the channel when new episodes get posted, and for everyone who supports the channel in any ways that they have supported the channel in the past and in the future. A couple of ways are through some small monetary donations through Patreon and a few other things. Also with some donations of equipment and things like that, so I can get things in front of the camera to put on the bench. Everyone who has done anything for the channel over the past 3 years, you guys have helped make the channel the way what it is today, and will continue to do so into the future. So thanks again, and it helps more than anyone knows, and also helps in steering the channel to make it what everyone would like to see on YouTube. This video is actually specifically a introduction video on how to evaluate a scope that has just arrived in the lab that you know nothing about. Whether it's come in for repair, it's come in from an auction website, it's come in from an estate sale, it's come in from somewhere. I'm getting a lot of questions based on the history of videos on the channel about, hey, I got this new scope, what's it doing, and where do I go from here? It's on the bench, and I know nothing about it. How do I get started? So that's what I'm going to try to cover in this video. If I leave anything out, please add it to the description down below. I want this video to be a community resource for some time to come. I'll be using this scope as a example. Any 400 series scope follows this format except for the 485. The 485 has a different front panel layout. But so this particular scope, we'll get the cover off. One, the cover's in great shape on this. So scope just hits the bench, everything's good to go. The cover's in good shape. There's no cracks. There's no spills or anything. I can't see any obvious liquid damage. On the back of the scope, there's a couple of cracked feet. That is par for the course for these particular units. There's even 3D printable replacement feet for the back of the scope, which I'll make a set for this one. So that's a common failure point. The rubber hasn't aged well. Rubber typically doesn't age well, at least when it gets this old. So that's a start. Visually, the scope looks to be in good shape. We can tell by the bump out here, this one's going to have a DM44. Personally, my least favorite scope to work on is a 475 A, non-A or A with a DM44. Guaranteed there's the most stuff wrong with it. That happens to be what this one is. I knew what I was getting into when I told its owner I was going to put it on the bench and get some time in it. This one, let's see, I haven't even looked at this yet. So, well, initial reaction is it is amazingly clean, which is something you want to look for, hopefully in pictures, but definitely as soon as you get it. Just some of the things I'm looking at the front. The knobs are intact, the skirts are intact, the buttons look all good. Actually, the paint's not worn off on any of these buttons, which also tells me the scope doesn't have a lot of high miles on it. The trigger knobs tend to get bent over time. These lever switches never seem to get broken. I very rarely run into a scope where any of those are busted, but these definitely get bent. So this is looking very good. So that's the first thing to take a look at is the scope complete? Now, a couple of the things that I'm looking at before I even open it up is any of the knobs busted? Are the controls, are these lever switches in here? If you remove the trigger board, these levers go with it. So if you see a scope that doesn't have these switches in there, pass on it. It's missing a board. Guaranteed it's missing a board. But from the front of this, everything looks good. Now, given that these are usually shipped, I've seen it where these buttons, this doesn't look too bad, but the scope won't work. If I apply power to this, assuming that everything was good, the button configuration on the front of this will not function. The channel selector is completely out. I don't have any channel selected. My horizontal display is completely out. I don't have any horizontal functions selected. and I don't have a trigger selected, auto, normal, or single sweep. So first thing to do when you get a scope like this, before you even apply power to it, is make sure channel 1 selected, A-lock knobs is selected, and auto is selected. That will set up the scope and put it in a mode where even if there's no signal on the front end, theoretically you should get a sweep across. The other thing you want to do is flip these levers to their topmost position. One of the things that Tech did, and I'll even do this too, because this was trigger control was way over, was they designed the scopes that if you can't, for whatever reason, find the signal, center all the controls, flip the knobs all the way up, you should get something on the display. That was just kind of the way the scopes were laid out and done. Since I'm just glossing over it and I notice it, the other thing is the VAR controls are all correctly oriented. If any of the VAR controls are flipped over, spun around like that, that means it's not in the calibrated detent. And for the variable controls, it's an attenuator too, so it can be all the way down. You wouldn't notice it. So you want to take the red knobs, rotate them all clockwise till they click. The other thing you want to do is kind of feel the controls. I really wish YouTube was Feel-O-Vision, because there is a drastic difference in the way the controls feel from when something hits my bench to when it's finished for repair and off back to its owner. The rotate all the controls through their ranges. See if anything's binding. Don't force it, as noted with the 7A29 plug-in. If you crank on a control and force it, you can actually permanently damage the control and break off some of the internal mechanism. This is also true with these 400 series scopes as well, due to the fact that some of the controls have plastic actuators and things like that, and this plastic is starting to get north of 50 to 70 years old, depending on when they're made. It's really starting to get brittle, and as we all know, brittle plastic tends to crack and break. A lot of these scopes aren't stored correctly. Well, I can't say stored correctly or not, but they're not stored optimally. If sun hits the front of the panels too much, even though it's through a window, the UV can eat the plastic. So you'll, I think that happened to me in one of the 475 videos, where I turn one of the knobs and it literally just crumbles in my hand. That's just brittle plastic over time. There's not much you can do about it other than replace or repair the knob. Replacement is typically the more common. This one was stored very well. There's not even much tarnish on the BNCs. A scope that's stored in, say, a crawl space or a basement or a garage or something like that can get corrosion on. Actually, here's a good example. Can get corrosion on the BNCs. I also try to look for this as much as I can when I'm looking at photos to see what would be a good repair candidate. So let me zoom in up here. This is a BNC that's got some corrosion on the outside. Plus, it's got the center connector. It's working, but it's real dark. It's got a bunch of corrosion in there. This one's working okay. The center conductor on these is also dark, but the barrels are in great shape. Now, the important part is this ring, too. This is a 2-part BNC. I don't know if you can see the insulator right here going around the BNC. That's part of the identification circuit and the autosense circuit for the range lights on the scope. It's a resistor from this ring to ground, and if the resistance value is right, it'll switch which range is displaying on the front of the scope. In case of a 7000 series, it'll switch the readout. But if this is shorted to the barrel, which I've had a couple of times, it will show identify. So if you hook a plug-in in and it's got one channel that's stuck in identify, before you do anything else, check for a short there, see what happens. So we've got the scope in. Controls are all feeling good. What do we know for this one, knowing what I know about a 400 series scope? What do we know is going to be wrong? Well, if it's a 475 or a 475A or non-A, doesn't matter, I know I'm going to have to replace 15 transistors. It doesn't matter what the scope is. It doesn't matter when it was made. It doesn't matter what was going on. There is a known bad transistor that gets leaky in the 475s. That transistor was not used in the 465s or the 485s, but it was used extensively in the trigger board of the 475. I do know the scopes will work with the leaky transistors, but especially on some of the, one of them is actually used in the blanking circuit of the CRT, which is a critical function. You don't want the blanking circuit disabling and driving the tube at full power. Just know if it's a 475 and it hasn't been done, you're going to need to replace the transistors. I do have a video, which I will link in the description, that goes into detail about those specific transistors, why they're bad, and where they are in the scope to be replaced. The next thing I know is going to be bad, given the fact that it's a 400 series unit. I'm going to have to clean the attenuators. I have not, in any of the tech scopes that I've run across, the time-based switches seem to do okay. The attenuator switches, forget it. They're noisy. All of them. And it doesn't matter, 7,000 series, 400 series, 5,000 series, does not matter. These switches are dirty by now. They will need cleaning and servicing. It is a pain in the butt, but it does need to be done to get the scope back up to functioning. I've got a couple plug-ins on here where I have to exercise the switches. They still, even after doing all the servicing, they're still a little weak. So I have to exercise the switches a few times. The other thing that's a good plan to do is leave the switches at their highest range when you turn the scope off. This will do two things. One, it'll set it to where if you have a 10x probe on here, this is 100 volts per division. If you fire the scope up a couple days, a week from now, you plug in a signal, guaranteed you're not going to blow anything up because you're at the highest attenuation setting. If it's down here at the 10 millivolts, you can overdrive the input attenuator and do some damage. So it's always a good idea to leave the scope on the highest range, which would be that position. What is this, 0.5 milliseconds per division? No, 0.5 seconds per division, 500 milliseconds, and 100 or 10 volts per division would be where that was at. These switches in the 400 series aren't as much of a problem as they are in the 500 and 5000 series, not 500 series scopes, TM 500 and 5000 series equipment. Typically, these switches need a little bit of cleaning, but they're not real bad. That's true for the trigger view, the invert and the beam finder, and the 10x magnifier, as well as the trigger controls. The beam finder switch is a source of pain and frustration in these scopes. If this, a lot of the CRT drive signals go through this switch. So if this switch is dirty in any way, you will have all kinds of noise on the display. So if you're running into unexplained noise that just doesn't seem to go away, that doesn't make sense for any of the other controls, like attenuator noise is pretty easy. That's in the vertical only, but not the horizontal. If you see horizontal noise and you're not adjusting the horizontal control, or the vertical, or you get horizontal noise with vertical control, hit this beam finder switch and clean this really, really well, because yeah, the CRT drive signals go through there. Because what this does is it compresses the screen, so it doesn't matter where the beam is positioned on the screen, you can find it. But that does affect, it sits, I believe it's after the vertical amplifier, but before the actual drive amplifier for the tube. Because the drive amplifier for the tube is, if I remember correctly, it's like 200 volts to the plates of the tube to get the drive, the horizontal and vertical deflection drive. We know the attenuators are toast. Being that it's a 475, we know we have transistors that we're going to have to replace. Is this safe to power up? Good question. It's a device of unknown electrical history that has showed up at my door, my bench, your bench, wherever it happens to be. The next important thing is everything looks okay mechanically. Boards look like they're there. Nothing's smashed, caved in. There's no obvious damage. So we're at the point where we need to make a decision of, do we plug it in and electrically test it or not? Well, it really helps to know the power supplies in these. One of the common tech steps is to bring it up slowly on a variac with a dim bulb tester. I have a substantial variac and dim bulb set up in the lab and use it regularly along with an isolation transformer and a few other things. However, on a 475, it would be okay to bring it up on a dim bulb tester, but that can stress some components in there due to the fact of the way it works. Dim bulb testers are great for linear power supplies. They are not very good for switching power supplies, because what will happen is, as the supply starts up, the switching supply, which tends to have feedback in it, will try to boost the voltage to get the regulators to the point where they can actually do their thing and start regulating. If the voltage sags, the way it makes up for that is it has to draw current. So what will happen is the device under test, in this case a 400 series scope, will spin up and it will start drawing heavy current, which will cause the voltage to sag through the dim bulbs even more, to the point where it'll get down below its cutoff threshold and it'll actually start to sit there and kind of oscillate a little bit. That power supply oscillation is very hard on these units. The other thing is, if you look at the schematic on these 400 series scopes, it looks like every single scope has a switch mode or a linear power supply in it, except the 485. Well, yes and no. The 485 has a fully switching power supply in it, nice big bulk caps that tend never to go bad, and a few other things. All of the 400 series scopes have a switching power supply in the high voltage section. They get the tube voltage from I want to say it's a 4 kilohertz switcher, I believe, if I remember correctly. But it's a switching supply that goes into a voltage doubler or tripler, and then it comes out to the tube at about 7,000 plus volts, negative, typically, because the negative 4,000 volt supply, which you measure as part of the calibration process, goes through a voltage tripler. Well, if it goes through a voltage tripler, that means it's a negative 12 kV, which is quite high, and actually very hard to measure. That's why they do the calibration step on the 4,000 volt side, which is still hard to measure, but not nearly as bad as the 12 kilovolt side. So, that all being said, I know this one was plugged in before it came to my bench. So what I'm going to do is I'm going to hook it up to a fused load, which has a fuse, very light fuse in it, big enough where won't blow during startup, but if anything goes too haywire, it'll pop pretty quick. And we also have some current monitoring through my lab power supply, so we'll monitor the scope for startup. What I want to do is, just in case, I want to defocus the tube, and I want to make sure the intensity is all the way down. That way we'll get an idea on if the scope is healthy or not. But if something does go completely haywire, like if something's failed in the brightness control circuit, the full brightness of the tube it'll light up the front of the tube like a Christmas tree. And that can cause, well, you don't want to run the scope doing that too long because of just very rapid aging of the tube. So at this point, we have all the controls set. I'm going to speed this up a bit. A, auto, these are up. We have triggers centered, positive, positive. We're on channel 1. The AC-DC ground switch is in DC, which is fine, and our position control centered. So that should give us a roughly flat line somewhere on the display without too much trouble once we turn the intensity up. Now remember, we have the intensity all the way down, so getting some initial questions about the scope answered before anything goes too haywire. I'm also very concerned what the display does when we do power this up on this DM4400. There are some custom tech chips in the DM44 that are known to be problematic. Most of the TTL logic that's in here typically is not problematic. However, the custom ones are known to burn out. That is usually indicated by a very strange display. We'll set the DMM44 for 200 millivolts, and we'll set it on the volts range. Essentially what I'm looking for here is I just want the display counting. So I'm not worried about overall accuracy. I'm not worried about anything else. As long as it's counting, we're good to go. And that kind of tells me some troubleshooting in the beginning. Now, when the display comes up, I'm going to be looking at, do I have lights for my selected channel? Essentially, having the scope, I'm familiar with the way they're supposed to work. I'm just trying to find a baseline of, does the scope work? Is it doing what I expect it to when I move the controls? Like if I move the sweep time knob, does it slow down or speed up? I don't care about accuracies at the moment. I'm just looking for sanity. Let's see, center this position control. That was way off too, so that would have thrown the display way off to the side. And I'll show that when it comes back up. But all right, so let's apply some power to this one and see what happens. We've got 124.5 volts RMS coming out of the wall. And we're going to turn it on. Power light came on. Oh, no, sorry, that's low line. That should not come on. My indicator did come on, which is good. My meter is counting, which is good. My current draw is about 45 watts, which is also good. So the initial and the checks need to be about that fast, because I'm also listening to the scope for any kind of like electrical sizzle. I heard some static from the tube. Now, that static is important because that static gives me a clue that the high voltage is there. So if I didn't hear that crackle of static, it could mean that the high voltage section was dead and isn't functioning. One of the ways I would test high voltage on TVs back in the day when TVs were CRTs is I'd take the back of my hand and I'd run it this way up against, actually, it still works with the scope too. You can feel the hair stand up on the back of your hand. If that does happen, that means the high voltage is probably present and working. So that's actually a good, healthy sign. Without even opening the test gear or warming up the lab, getting out a probe or anything like that, we've already got a lot of good information that the scope might be healthy and working. So let's give it some brightness. Well, that's not good. Okay, so we're into our first issue of we don't have... Actually, I don't have two functions. So this is where we start getting into information gathering. At this point now, the scope is not working. It is faulted. We know we have work to do on this unit. Now the question is, what can we get it to do? Beam finder doesn't do anything. Focus doesn't do anything. The other thing that doesn't do anything, which I'm kind of concerned about, is our graticle illumination doesn't work. So that tells me right off the bat we're missing a power rail. Probably has something to do with our unblanking. And so we are going to have to go into this scope and start taking some measurements. Scope troubleshooting 101 is make sure all the power supply rails are there. I can almost guarantee we're missing one, and I haven't even looked at a schematic. So we'll see if we can get it to do anything. Our channel switching is working. Be intensified. Nope. I wonder if we can get it to trigger off of anything. Actually, let's set it to line. Our 10x magnifier does work. That works. I was really hoping for a trace so we could go into it. Okay, at this point I would recommend grabbing a computer and internet connection and downloading a copy of Troubleshooting Your Oscilloscope, Getting Down to Basics, as written by the Tektronix company. One of the things they recommend doing is gathering as much information as you can off the front of the unit before you even go inside and start taking measurements and troubleshooting things. Doing that can point you into the direction of which board is faulted and things like that before we even get started into figuring out why things aren't working the way they're supposed to. Now, everything in there, it's wonderful information. It's great to have in the back of your mind. Keep in mind, everything in there is assuming the scope is not 50 years old. So a lot of the troubleshooting steps are there would be when the components did not have this much time and age on them. That makes the troubleshooting a little more difficult and less straightforward. So to check some power rails, here's the busted feet. These are normal. There are a couple power rails like the negative 15 volt rail, the negative 8 volt rail, the positive 15 volt rail. They're used absolutely everywhere. If any of those aren't in spec and working the way they're supposed to, none of the troubleshooting steps are valid until the power rails are there. But given that we don't have any graticule lights, it's almost 100% given one of the rails is missing. This screw, is it? It looks a little blown out. So we may not be the first ones here. That could be a problem. That's the other thing is, if you're looking at grabbing one of these units, I'm taking this out apart in real time. Try not to get someone's parts unit unless you want a real challenge. These are quite complex units themselves already, but grabbing someone else's parts unit, I've been down that rabbit hole a few times. It can be a pretty deep one if there's even a bottom. I did have to call one scope that we were working on for somebody, and I just said I just started peeling back the onion, and every time I looked at the scope there was more and more and more things wrong with it. So it can get very deep very fast. The DMM needs to be opened up. Give me my screwdriver back to pull the cover off, if I remember correctly. Ooh, this one's still got the plastic. And then the scope punches forward. And slides out. Okay, it goes without saying that the investigation of the power supply rail has to be done with the scope on. This is a necessary evil. If you do not feel comfortable working with voltages of low to medium voltages, including some high voltages, do not attempt what is shown in the video. So here's our power supply section. Let's see what we've got. We've got our meter up here. We'll make the numbers bigger for everybody. We'll go on the... Actually, I'm going to... Because that's being kind of slow. I'm not looking for speck and ripple at this point. I am just looking for kind of sanity check the power rails. Is it present? Is it remotely close? Now, fortunately, having done a bunch of calibrations on these, I know where the power supply section is. It's on the bottom board of the scope. And it is relatively well marked. And first problem already. Our negative 15 rail doesn't exist. We have a positive half a volt on that, so first issue. How about our 110 volt rail? 110 looks okay. 50? 50's fine. Plus 15. No, plus 15 rail is dead as well. Oh. Well, that's not good. Plus 5? Yeah, plus 5 is okay. Minus 8. No, minus 8 is dead as well. So the 3 most commonly used rails in this unit are dead and out to lunch. Well, that explains our problems. A thermal imaging camera would be very helpful in this situation, because it would give me an idea on what's getting warm and hot and things like that. Next troubleshooting step would be just to spend quite a bit of time looking at the unit, seeing if there was anything visually obvious, burnt, tantalum capacitor, something like that. Obviously, we have shorts on the power supply rails, and before this thing works again, all of those are going to have to be corrected. I run into this a lot. Again, cosmetically, the scope is in really good shape, and it does deserve to live again, but I get the feeling this is going to be a rabbit hole, but we'll see what happens. So any deeper troubleshooting, and this would have gone into a restoration video on this particular unit. And I don't want to get into that in this video too much, because this was just supposed to be a quick intro on what to do when a scope hits your bench. But I can't plan these things. They just show up, and the scope is what the scope is, and that's it. So, well, let's one more check. Let's see. We're going to unplug the scope from power, let everything drain off. And then another good check of the scope is with no power applied, because it can blow up an ohm meter. Let's do some 2-wire measurement of the power rails. Our plus 15, dead short to ground, 0.4 ohms. 5 volt. .45 ohms. The 5 volt was good. Negative 8. 30 ohms. Yeah, that one was okay. The negative 15 volt rail has a 34K ohm reverse biased. What's... Yeah. So that already tells me my problem is on the 15 volt rail. So next stop is tantalum capacitors. There's a dead one somewhere. Can almost guarantee it. Okay, so moving over to this 7603, which is fully restored and fully functional. A couple of things that I would have done if we had gotten a trace out of that 475, although we'll get a trace once the 15-volt rail's fixed, is if the scope isn't in auto mode, so if it's in normal mode, it can look like, because there's no trigger, there's no beam. Auto mode, there's a beam. Normal mode, there's no beam. The unblanking only happens when it triggers a sweep, and because there's no input signals, there's no trigger. So another thing that can look a little weird is if the position is cranked to one side, it can look like the sweep is messed up. So that's why centering the controls is so important. And also for the time base, just making sure, without smoking my tube, just making sure the control sanity check as I speed up the time base, does the sweep go faster? One other thing to check with all tech scopes is defocus the spot. Oops, that's graticule. Focus on this guy is a screwdriver, so I'm not going to do that. But defocus the spot, and what you want to look for is you want to run the intensity control through its entire range very quickly. Don't leave it sit on high beam for too long. What you're looking for is called double peaking. So what happens is if the trace gets brighter and then dims out and then gets brighter again, stop troubleshooting the scope. It's a high-hour tube. You're either going to need to source a tube or it's a parts unit. There's a lot of speculation on why the double peaking occurs. However, it is terminal to the tube. There is no fixing it. Now, on a 400 series scope, definitely easy to find a tube, relatively easy. There's parts units everywhere, so a tube can be picked up relatively inexpensively. For a unit like a 576, which I actually have two, here are two 576 CRTs. This one, it's kind of obvious. This one's been in the sun for a while. Even the graticule's been bleached fairly badly. These is also two different types. This is the 10 or the 12 graticule. So this is the 10 by 10, and this is the 10 by 4. So both of these would run a 576, just two of the tube options. They're both exhibiting the double peaking. This one, and as you can see, there's no burn-in. Obviously, the graticule on this one is in very poor shape, but this one looks brand new, but there's no brightness. It's good to know what's terminal immediately, and then you can go, okay, I need to stop troubleshooting and cut the repair and move on. This particular scope, this is infinitely repairable. As long as the tube tests okay once we get the 15-volt rail back. So I can't show, I'll show attenuator noise in the next video once I get the troubleshooting done in the power supply. We will be doing video restorations on this scope, so no one will miss anything. Don't worry about that. But I can't do any more until my 15-volt rail's back, which we will find out. The numbers counting on the DM4400, that was a very good sign because it looks like that DM4400 is going to be okay. Probably just need checked in alignment, which is not a big deal. I'm going to add a link to the how to troubleshoot your scope in the description for this video down below. And I do hope this video helps get started once a unknown 400 series scope shows up at the bench. So if anybody has any questions, I will see everyone in the comments section below. I do read all the comments. May not have time to respond to all of them, but I do read every single comment. And I will be there in between video releases. As always, more is on the way. And if you found this video helpful, go ahead and hit the subscribe button. And I will see everybody in the next video. Bye for now.